Hey friends, today on 1 Minute Math we're going to be looking at polynomial division. This is probably a concept that you're encountering in an Algebra 2 or a Pre-Calc class. The good news is that this is not a concept that you really need in a huge way moving forward. It is definitely something that you should be able to do. Like, it's good that you're learning about polynomial division in your Algebra 2 or your Pre-Calc class. This tends to be a very confusing and very difficult topic for a lot of students, and it is not something that comes up again in calculus or in statistics in a big way in the future. So that takes the pressure off a little bit, but we still want to make sense of it. So the key here is, like, the basic premise is that we're given one polynomial, like this guy on the top here, x to the fourth minus x cubed minus 11x squared plus 19x minus 12, and we are dividing it by another, presumably smaller polynomial, like x minus 3. This would be the kind of thing that you might be asked to graph. Maybe you want to figure out where its zeros are, or find some kind of, whether it's positive or negative. All of that stuff can be made easier if we can actually divide these polynomials and simplify. In the same way that if I asked you to do something with the number 89 thirds, okay? It might be easier if we could simplify this a little bit, to figure out its magnitude, its relative size, to maybe look at it not as this big improper fraction, maybe as a mixed number, or if I could get one, if I was looking at 90 thirds and you wanted me to do something with the number 90 thirds, it would be much more convenient for me to recognize that that's the number 30. That's sort of the premise that we're working with here. It's going to be more helpful for us to deal with these expressions in a smaller way if we can simplify them. We can't always simplify them, but we can try. And here's the easiest strategy I know for polynomial division is something called synthetic division. I'm going to show you that strategy first. In this video, I'm going to show you two strategies, synthetic division and regular old polynomial long division. If you learned long division in elementary school, like dividing numbers, the polynomial long division might make a lot of sense to you. If you didn't, and even if you did, this synthetic division is a great shortcut. Synthetic division. So here's how we do synthetic division. I'm going to take the coefficients of my polynomial that is on the top. I'm just going to write them here. 1, -1, -11, 19, -12. Just the coefficients. I'm going to give myself a bar down here. I'm going to take my my root on the bottom. So not necessarily the number that I see, but I'm imagining what is the root? What makes that denominator equal to 0? In this case, that's the number 3. I'm going to put that up here in a little box. He's going to be my multiplier. I'm going to use him a lot. The first thing I do is simply drop this first coefficient down. So just follow along with this random thing I'm going to do here with the numbers, and hopefully it will make sense. I'll stay in gray. All right, so now I'm going to multiply 3 times 1, and that gives me 3. And I add the two numbers that I see there stacked up on top of each other. -1 plus 3 is 2. And I do this again. 3 times 2 is 6. -11 plus 6 is -5. And I do it again. 3 times -5 is -15. Just adding straight down. 19 plus -15 is 4. 3 times 4 is 12. And when I add those, I get 0. If we get 0 here at the end, that's a very good thing. I'm going to put him in 0, that 0 in yellow, because I'm going to make him a smiley face. Yay! If we end with 0, then these polynomials divided without any kind of remainder. That means that x minus 3 was actually a factor of that gigantic polynomial on the top. X to the fourth minus x cubed minus 11x squared plus 19x minus 12. That is x minus 3 times something. And like, that mystery something is what we actually just figured out. It's kind of hidden in code here. I had x to the fourth, and I divided out an x term, so I am going to end up with an x cubed polynomial. 1x cubed plus 2x squared plus -5x plus 4. That is my quotient. That's my answer. This polynomial division equals x cubed plus 2x squared minus 5x, I'll just put that plus, negative is minus, plus 4. The end. That's synthetic division. Put the root in the top and kind of multiply on, and you're just adding adding straight down every time. We're going to do it again here in a little bit. But before I do that polynomial, that synthetic division for you one more time, I'm actually going to take a minute here and do a polynomial long division example. Get this stuff out of the way. All right, with this guy, we're going to try polynomial long division. If you remember, like, let's take an example from elementary school. 4, 3, 2, 9. Let's divide that by 5. Okay, so we say, all right, how many 5s go in 4? None. So I go to the next number. How many 5s go in 43 would be 8. 8 times 5 is 40. I subtract. Get a 3, pull down another one. How many 3s go into 32 would be 6. 6 times 5 is 30. And then I get a 29. How many 5s go in 29 would be 5. And in this case, I would have a remainder of 4. All right, that's kind of our pattern that we're starting with. We're going to do that same sort of process here, but with polynomials instead of numbers. So 5x to the 4th plus 9x cubed plus 6x squared plus 9x minus 14 divided by x plus 2. And I'm going to focus on the first names of my terms like one at a time. So if I divide, the first name of this giant polynomial is 5x to the 4th. The first name of my divisor is x. 5x to the 4th divided by x. I'm basically asking, like, what do I have to multiply this by to get that first term? And that would be 5x cubed. So I'm going to line that up with cubes. 5x cubed. I multiply those just like I would have in numeric long division. 5x cubed times x plus 2 is 5x to the 4th plus 10x cubed. All right, and I'm going to subtract those. 5x to the 4th minus 5x to the 4th is 0. 9x cubed minus 10x cubed is negative 1x cubed. All right, so now I do it again. Let's go ahead and bring this next term down. Boop, 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 boop. Plus 6x squared. How many x's go in negative x cubed? Now the first name of the thing I'm dividing is negative x cubed. So I'm going to divide negative x cubed by x. And I get negative x squared, so that's what goes up here, minus x squared. Multiply it down, minus x squared times x plus 2 would be minus x cubed minus 2x squared. So I'll subtract those. You got to be really careful with the negatives. That's the only real tricky part here. All right, my negative x cubes canceled out. 6x squared minus negative 2x squared is 8x squared. Bring down my next number, which is this, 9x. How many x's go in 8x squared is 8x. So it would be 8x squared plus 16x, subtract them. The 8x squareds cancel out. 9x's minus 16x's is negative 7x. Bring down my very last term. Minus 14. And this will be negative 7x. I'm sorry, just negative 7. I almost said negative 7x. Negative 7 because negative 7 times x. There we go. Negative 7 times x plus 2 is negative 7x minus 14. Again, I get 0. It's very happy when we get 0 down there. And there's my quotient. So up here, I could say this ridiculous division equals 5x cubed minus x squared plus 8x minus 7. Bum-ba-dum-bum. So that's polynomial long division. We're going to practice some synthetic division one more time here. Actually, I think we're going to do it 2 more times. I might move this guy to the next slide, though, so I have a little bit more room to write. Let's just go to the next slide. Beautiful. All right, and I'm going to do synthetic division again. If you're looking at this, you notice a couple of things. I've got an x to the 5th term, but then the next term down is x squared. It kind of like skipped over the 4th and the 3rd. So if I'm gonna make my coefficient like columns here, I'm going to start with 1x to the fifth, but then I have 0x to the fourth, 0x cubed, negative 2x squared, negative 1x, and 2. The other thing that we notice here is that I actually have two different zeros in the denominator. X squared minus 1, it could be factored as x minus 1 times x plus 1. So I've got two different roots, and I'm just going to take them out one at a time. I'm going to start with 1. That was that guy right there. I'm going to start with 1, and I'm going to do my synthetic division on him. So if you didn't catch it the first time, you get to see it again. This number just comes straight down. And because the number I have up here in the box is 1, because my root is 1, this is going to go real fast. 1 times 1 is 1, 0 plus 1 is 1. 1 times 1 is 1, 0 plus 1 is 1. 1 times 1 is 1, negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. Negative 1 plus negative 1 is negative 2. And 1 times negative 2 is negative 2, smiley face. That was an x to the fifth dividing out one root, 1x. So this is going to be x to the fourth, x cubed, x squared, x, and then my constant term. I'm going to take that expression, 1x to the fourth, 1x cubed, 1x squared, negative 1x minus 2, and I will divide out from that my negative 1 root. And this one will be a little bit trickier because of that coefficient being negative, but it's not terrible. Negative 1 times 1 is negative 1. Add them up. 1 plus negative 1 is 0. Negative 1 times 0 is 0. 1 plus 0 is 1. Negative 1 times 1 is negative 1. See, I'm doing like boop, boop. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 2 is positive 2. 0, smiley face. This was an x to the fourth polynomial dividing out 1x, which means my first term here will be x cubed. So in the end, I get x cubed. My final answer here is going to be x cubed plus x minus 2. So I had 0x squared. I just divided out one root, then I divide out the next one. For our last example here, we're going to do synthetic division again, and we'll just see what happens. You get another example here of synthetic division. So let's just divide this one out and see what happens. I know what's going to happen because I'm the one who made the slides, but I want you to see what happens. So far, we've had these all kind of work out nicely, and we get that fun 0 at the end. Get to put our smiley face in it. It's awesome, but that doesn't always happen, and that's okay. All right, so I set up my coefficients: 2, 12, 7, negative 14, 3. My root is negative 5. And here we go. Bring the 2 straight down. Then we multiply across. Negative 5 times 2 is negative 10. 12 plus negative 10 is 2. Negative 5 times 2 is negative 10. 7 plus negative 10 is negative 3. Negative 5 times negative 3 is 15. Negative 14 plus 15 is 1. Negative 5 times 1 is negative 5. And I got something that wasn't 0 at the end. Well, let's see what happens. I had an x to the fourth. I divided out a single x term, so I'm going to end up with x cubed. 2x cubed plus 2x squared minus 3x plus 1, and this is a remainder term. What that really means is that my quotient that I started with is 2x cubed plus 2x squared minus 3x plus 1 plus 2 leftover bits that couldn't be divided out. So I've got like that fraction on the end. If you remember my very first example, I was talking about if we had 89 thirds, okay? This ends up being 29 and 2 thirds, like I said, 29 and 2 thirds. 29 times 3 is 87. So 89 is like 87 plus 2 extras out of 3, or 29 whole 3s and an extra 2 thirds, which we would write as 29 and 2 thirds, like that as a mixed number. This expression is like this way of expressing my quotient plus a remainder with the original denominator. All right. So this is how you do polynomial long division, polynomial synthetic division, how you divide polynomials, and what your expected result should be. In the end, you should have something that is either not a fraction at all, there are no rational components, or you have something of one remainder, like a numeric term, that is going to be a remainder, just a single number divided by your denominator. If you have those two roots on the bottom, you just divide one out and then divide the other one. So I hope that makes sense. Thanks for watching.